Hello and welcome to my talk. My name is Benny Halen and I'm a principal architect with Insight Digital Innovation. We're both a Microsoft and a Databricks partner, and we're very proud to have received the Databricks APAC Partner of the Year award last year. We have recently implemented a solution for one of the largest municipal fire departments in the country, and we'd like to share some things we did for them. Specifically, we built a real-time reporting channel for them with Azure PaaS services, Databricks, Spark Structured Streaming, and Power BI. So let's get going. So I wanted to first describe quickly what we already implemented for the fire department. So this is a large metropolitan fire department, and we implemented a complete modern data warehouse architecture on Azure for them. And this architecture is based on Insight's repeatable MDW framework architecture. So with this architecture, they can ingest data from a variety of sources. So it could be SQL, could be REST APIs, SaaS services, etc. We ingest the data, we can land it in the raw zone. From the raw zone, we can then cleanse and transform the data, land it into a staging area, and from the staging area, we can build dimensions and fact tables and land those in the MDW area. From the MDW area, we can then push the data either to Azure's analysis services or Azure Synapse. And then finally, the visualization itself is performed by Power BI. So in this architecture, we have a set of reusable templatized ADF pipelines, and these ADF pipelines are used for both data movement and for scheduling. So while this architecture works great, it's been in production for quite a while, the fire department recently came back to us and asked for a real-time reporting channel. So we'll take a look at what their requirements were here in the next slide. So what was the extension of our use case here? Well, the fire department wanted this real-time reporting channel where they would get an up-to-date location and status of all their equipment. So that includes fire trucks, ambulances, et cetera, et cetera. They also want to know the location and the status of all their personnel, including the firefighters, EMT personnel, and really anybody working for the department. And then finally, they want to know what's going on in their city. So they want to know, what are all my active incidents? What accidents are happening? Where are the fires, et cetera, et cetera. And they wanted to take this data and provide a real-time visualization for it. So they wanted to create an automatically updating dashboard, and a very important component of that dashboard was a map which would provide automatic updates of locations and incidents. And importantly, that map should be automatically updating based on data triggers. And that map and the complete solution really would be used by fire chiefs to make real-time move-up decisions where they preemptively move up equipment and resources as incidents are happening throughout the city. And it's anticipated that down the road will actually help them implement some AI algorithms to help drive those decisions. So let's take a deeper look at what we need to build here. The incidents themselves are sourced from quite a variety of systems, the main one being the 911 system itself, but then we have GPS trackers, etc. All these events land into the Central Fire Department's database, and we leverage a change data capture CDC infrastructure to get those events and then ultimately forward them to an ESB, an enterprise service bus, which in this case was typical rendezvous. So all this infrastructure was existing infrastructure that was set up by the fire department. Insight tapped into the enterprise service bus through a WebSockets interface. So we built a component that received the events through the WebSocket interface and then used Azure Functions to forward those events to our cloud ingestion channel. And we'll take a look at our architectural requirements for our cloud infrastructure next. So what are our architectural requirements? Well, we need to ingest the event stream. We anticipated a high, at least 1,000 events per second. So we need a very high ingestion rate. So we need a really high performance, fault tolerant ingestion service. We need to stream those events off the ingestion service, and then we need to do some domain-specific conversion and real-time streaming analytics on that data. Once we streamed off the events and converted them, we want to store them in a very high-performant data store where we can have keyed access to the data, so we can refer to units by a unique identifier. And then, importantly, we need to perform upsert operations, right? Because we want a real-time representation, a real-time view of what's going on. So we need to be able to perform an upsert where we merge newly arrived events with already existing data. And then last but not least, we need to visualize that data in the real-time dashboard. And as we mentioned before, we want updates to be triggered by data changes in the underlying data store. So now that we know the requirements, let's see how we actually decided to build this solution. So in our solution architecture, we chose Azure Event Hubs as our ingestion channel. Azure Event Hubs is an industrial strength, a very robust ingestion service that can literally process millions of events per second, so well beyond our ingestion rate. It's high performance, fault tolerant. It also has a nice Kafka interface for both producers and consumers, so it allows us to integrate with that popular ecosystem. We chose Databricks as our analytics platform. Databricks offers a great solution for our cloud platform, which in this case is Azure. And then we combined Databricks with Spark Structured Streaming. Structured Streaming is a great analytics streaming service. And what's nice about it is it allows us to use the same semantics as we do for batch processing, since structured streaming is ultimately based on the same Spark SQL engine. And then we need to land the data. We chose Databricks Delta Lake as our data store because it's a high performance ACID data store. It gives us keyed access to data. It allows us to do those upserts that we mentioned earlier. And we can use SQL to access it, so it's very easy to access. So it really gives us that high scalable ACID big data store that we need to implement this solution. And finally, we select the Power BI as our visualization solution. It's easy to integrate, and Power BI can seamlessly query Spark and Delta tables directly with direct query. So we can issue direct queries and then directly visualize those results. And Power BI also has that capability to trigger updates through data changes. So it's a great solution here. So what we're going to look at next is a quick little demo. Since we can't tap into the fire department's live feeds, of course, I just created a small streaming event simulator. So that's a C#.NET application that simulates a little red fire truck that produces events. We created an event hub namespace with one single event hub called Units Event Hub. These events are streamed off Event Hub with a generic streaming notebook. And this notebook really only just reads the event off Event Hub, does some normalization, and then ultimately calls into a unit status event processor. And that architecture allows us to separate individual event processes from generic streaming infrastructure. So it's a nice pattern to implement. The event processor will update our unit status table that suddenly is that real-time view, and then we visualize through a very, very simple Power BI Premium report. The Delta table itself is built by a create Delta table generic notebook that's called by another notebook, and we'll take a look at that in just a second. So with that, let's talk about how we're going to organize this demo. So we first will take a quick look at what resources we stood up to make this happen. And then we'll do a code review where we look at the event simulator, how we created the Delta Lake table, our Spark streaming notebook, and our stream processor. And then finally, we do a quick run of the demo.
Next, let's take a look at our infrastructure. So we're here in the Azure portal, and we're in our resource group, our streaming resource group. First, let's take a look at our Event Hubs namespace. So this is your standard Event Hubs namespace, nothing really special here. What we'll do later is we'll take, for this shared access policy, we'll actually take our connection string primary key, and that was one of the items that we will need to store in our key vault. So next, let's go take a look at Event Hubs, and you'll see we have a single event hub called Units Event Hub, and that'll be the event hub we will use to actually store our events, and that's what we will be writing to, that's what we'll be streaming from. Let's go back to our resource group. Then second, we have our storage account, and this is a standard Data Lake Gen 2 storage account, and it has a single container called Data Lake. Within that Data Lake, you'll see kind of the classical organization that you see for a lot of modern data warehouses, where we have a bronze, silver, and gold area for the Data Lake. The bronze is typically where the extracted source data is landed. The data is then cleansed, and business rules are run, lands in silver, and then finally the dimensions fact tables are built, and they land in the gold area, and from there on are loaded either in Azure Synapse or in Azure Analysis Services. Next, let's go back to our resource groups. Take a quick look at the key vault. We mentioned the key vault there. We have only a few secrets we really need. We have a client ID and a client secret. That's the service principal that we use in Databricks to go and access the data lake. We have our connection string that we mentioned earlier for event hubs, and then we have the tenant ID for our Azure AD tenant. Okay, so we covered everything except, of course, Databricks itself. So let's go and launch the workspace, and we have a premium instance here because we want to do some things with Azure AD. So we have the premium instance, and here's our workspace. Let's take a quick look at the clusters. You'll see we just have, for the demo here, I just created a small little cluster, maximum of 2 nodes, nothing really special. Except for the libraries, we did install the Spark 2.1 library. So that is the Azure Event Hub Spark library that we will use to talk directly to Event Hub, to pull off events from the Event Hub. For the rest, we take a look at the workspace. We see we'll have a couple different folders. We have a startup folder where we have our script that mounts the data lake. We'll take a look in the code walkthrough real quick there. And then we have our actual streaming files where we create our Delta table and implement the actual streaming code. Finally, want to quickly point out in the data area here, we have, when we look at DBFS, we have set up a checkpoint directory. So this TMP unit status directory is actually a checkpoint location for our streaming process. And having a checkpoint location like this set up will allow us to seamlessly stop and restart our streaming process without any issues. So it's very important if you want to productionalize our streaming process. And so that pretty much covers our resources in Azure. Besides the Azure resources, I created a small little C#.NET program, and this .NET program is only used to kind of simulate a fire truck. So we have a little red fire truck here that will move across the screen, and we'll see that in the demo. So that concludes our infrastructure walkthrough. Thank you.
Now that we have taken a look at our infrastructure, let's take a look at our actual code, the code we wrote to implement our streaming algorithm.
Next, let's take a quick look at our code. We're here in the Databricks workspace, and let's start up by looking at the startup folder. We have a generic notebook here that can mount any ADLS Gen 2 storage. So you see we have 3 parameters. We take a storage account name, the file system that we want to mount, and the mount point path, how we want it reflected in our Databricks workspace. So here we set up our widgets. We pull some secrets from the key vault, so we need a service principal under which we will be accessing the account. So that's what our client ID, client secret is. We also need to pull our tenant ID. We get our actual parameters, and then it's a very simple OR2 setup here to set up our configuration, where we pass in our client ID and client secret and our tenant, and then ultimately use the ABFSS syntax for the data lake and mount the actual storage with dbutils.fs.mount. So that's really all there is to it. Very, very simple notebook here. Next, let's go take a look at our actual streaming code. So first we need to go and create our delta table. So again, we created here a very simple generic method, create delta table, that takes a database, a table, a schema, and the location of the underlying delta file. What we do here first is a simple little trick to use the schema and create an empty data frame out of that schema. So we pass in the schema here, create an empty RDB, and ultimately have our empty data frame, which will have the correct schema. We then write that in delta format to the specified location, and then next we drop and recreate the table and the database in the table, and then ultimately, quickly run a SQL statement and a describe statement to make sure our table was created successfully. So we can invoke this notebook from our create unit status table. So the only additional couple of items we need to take care of here is we need to set our database name, our table name, and our location. We create our schema. So this is our schema for the incoming events. And then next we just call the create date delta table method that we just saw in the other notebook, passing in our parameters, and here's our describe statement where we can nicely see that our table has been created successfully. So that's the delta table creation. Now finally, let's take a look at our streaming code itself. We really have 2 parts here. We have kind of a generic first notebook that just kind of sets up the skeleton of the streaming, and then we have a processing function that actually processes the events. So it's a unit status event processor. And this is kind of a generic pattern that we tend to use a lot, and it makes it really easy to create these generic processing functions which you can then hook up in more genericized streaming code. So let's take a look at the code itself. So we go and pull the event hub connection string. We set up our configuration, and then we call a read stream here with the format, of course, for event hubs. What this will do is we'll create a streaming data frame. So this is our unbounded streaming data frame that we receive back, and we see the schema here. This is the typical canonical schema for event hub. A couple things to note here, like you see, for example, the body is binary, a little bit hard to work with. So what we want to do is we want to take this schema and wrangle it into something that's a little bit more usable, which is what we do here with our good old PySpark with column methods. So what we do is, for example, is convert the body from binary into a string type, which will make it really easy in our processor function to go and pull out the JSON out of the message. So you see now, when we compare these two schemas, we got a nice clean schema here. And our final step here in the main processing logic is just taking the messages data frame and writing it with write stream. We'll skip the checkpointing for a moment, we'll come back to this. So we do a write stream and we do a dot for each batch. So which means take every micro batch and pass the data frame for that particular batch, the events for that batch, pass those on to this processing method, and then of course call the start method. So a couple things to note. Messages DF is still a streaming data frame because we read it here with read stream, but the data frame that will be passed to our micro batch method will actually be a regular data frame, which is great because that means we can count it, we can extract records for it. It's just a regular standard data frame that's very easy to work with. So next, let's go take a look at our processing function itself. And here, very, very simple logic. So we have our incoming schema that we set up. Let's take a look real quick also at our processing method. So you see here we get in this data frame that I mentioned earlier is a regular standard data frame now, and we get a batch ID, right? That allows us to track per batch ID what came in. We set up our schema, and then next what we're going to do is, because we're really only interested in the body of the message, so we're going to extract out the fields of the body and then do some transformations, so with column transformations, to convert timestamps, to pull out things like battalion, division, bureau, etc. And select all those out and get a nice clean unit status DF data frame here. We then drop our duplicates, make sure we don't have any duplicate records, do some debugging printouts, and then finally we go retrieve our delta table. So we use delta table for name to get a reference back to our delta table, and then we can just do our simple upsert, right? So we can just say delta table.alias and use our standard merge statement on name, because our name is the key of our table. And we can say when not matched, we're going to insert all, and when matched, we're going to update all. So standard upsert functions, nothing really special here. So that pretty much concludes the walkthrough of the code. So what we'll do next is we'll take this code and we'll do a quick run of all of this so we can see this in action. Thank you.
So now that we've taken a look at our code, let's run our simulator and let's run our notebook so we can actually see this in action.
Next, let's run our demo real quick. We'll start out here with our small little C#.NET event simulator. So what we have here is a little red fire truck. After all, we're talking about the fire department, right? What we do here is we create an event up, producer client, create an event batch, take the position of our truck and serialize that into an event, serialize that into a JSON string and add it to our event batch and send it to event up. Once we send that event, we increment the position of our truck slightly along these coordinates here and do this all over again. And as you can see, we have a total loop here of about 10,000. So that's our C# event simulator. So next, let's go look at our streaming code. So here we have our event up Spark streaming notebook, and let's go ahead and get this notebook in a running state. And as things are being set up here, we can see, you know, just like we did in a code walkthrough, right? We have a connection string that we read from the key vault, and then we use that connection string to do a read stream from Event Hub with our configuration, with our connection string. We see the schema here, so we've got a body that's binary, some offsets, etc. So next, what we do in the next statement here is just some simple with column PySpark transformations, so we can transform these columns into something that's a little bit more usable, and especially the body. So you can see here we're taking the body and casting that nicely to a string type, and that will make it a lot easier for us later to go get the JSON object out of that string. So here we have now a very nice clean schema with a string body and our timestamps. Next, we just simply have to take our messages data frame, and our messages data frame is of course a Spark streaming data frame, right? It's unbounded. For all practical purposes, it's the same as a regular data frame, but it is unbounded, which means rows are constantly being added at the bottom, and we cannot do things like take a count or take objects from it because it is an unbounded data frame. So we take the data frame, we perform a write stream, and we say for each batch that we collect, call this batch processing function. That's the batch processing function we looked at when we did our code walkthrough. One more thing to point out is here that we specify a checkpoint location, right? That we mentioned that earlier in our infrastructure walkthrough. So let's go take a look at our stream. You see at the moment, of course, we got nothing coming in because we haven't started our C# program yet. So let's go and do that now. So we'll crank up this guy, and you'll see that pretty soon here we should start producing events, and here we go. So when we go back, we'll see a little slight delay here. It takes always a couple of seconds for the status screens to update, but we should shortly see our events pick up here as we start receiving our events. There we go. So you can see our events coming in. We see, of course, our batch duration going up as we now have actual events to process. We can also go look at our raw data. So here, for example, we see we have 6,300 some rows per second, so we can see how what our processing rate is, etc. So always handy to kind of go take a look here. Switching back to our dashboard. And of course, if we want to, we can at any point in time, since we are ultimately updating the unit status delta table, we can go and run a standard SQL query to get the actual up-to-date status and coordinates of our fire truck. So here we see our lat long coordinates of our fire truck, and of course as we rerun those queries we see the position being updated. Finally, we can go take a look at our Power BI report, and we again see here our position. So we have a lat and a long of which is the current position of our fire truck, and we see it moving along the line there. So since this report has been set up to automatically update when my lat long changes, it will reflect those updates immediately without me having to refresh the report, which is a nice feature of Power BI Premium. Okay, that was a quick walk through. Thank you for your time.
The need for large-scale real-time stream processing is becoming more evident every day because organizations really need that ability to respond quickly to an ever-changing business climate. And what we've seen in this short little presentation is how easy it is to integrate Spark Structure Streaming to add a real-time channel to your architecture. It's very simple extensions on top of Spark SQL. So this is really a call to action. Go and implement streaming on your solutions and let me know how it goes. Thank you very much.